Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. We are still treating indeterminate form of a limit function. We are going to appreciate questions. Okay, let's see how we can apply the various techniques we spoke about. Okay, so the first question: evaluate the following. Lim as x approaches 1 of the expression x minus 1 all over x squared plus x minus 2. All right, so let's substitute 1. If you put 1 here, you will get 1 minus 1 over, you put 1 here, you get 1 plus 1 minus 2. So you have 0 over what? Over 0. So this becomes what? Indeterminate. Okay, so what are we supposed to do? We are supposed to use, or we are supposed to apply the techniques, right? So we can do justice to the denominator, right? Okay, so this is the same as we have lim as, let me do it this way. So I have x squared plus x minus 2. And this is the same as x squared plus 2x minus x minus 2, right? Then let's factorize. X is common, right? So I have x here, x plus 2, then minus 1, then I have x plus 2. Since this expression, they are the same, you pick one. So I have x plus 2, then x minus 1 in another bracket, right? So I can therefore say that, so this is just the same as the denominator, which is x squared plus x minus 2. So therefore, I can say that lim as x approaches 1 of x minus 1 all over x squared plus x minus 2 is the same as what? Lim as x approaches 1. I have x minus 1 all over. Now the denominator is equal to this. X plus 2. Then I have what? X minus 1. Is that not so? Now this expression is the same as this expression, so they will cancel out. I have 1. So therefore I have lim as x approaches 1 of 1 over, I have x plus 2. Right? So we will now apply the limits. So this is the same as lim as x approaches 1 of 1. Then all over, here is the same as lim as x approaches 1 of x. Then plus, I have 2 here. Lim as x approaches what? 1 of 2. So therefore, we have lim of a constant 1 is the same as what? The constant 1, okay? So I have 1, then all over, wherever I see s, I put 1 there. So lim of s as s approaches 1 is equal to what? Is equal to 1. Then plus lim of a constant is what? Is a constant, okay? So I have 2. So therefore I have 1 over 3. As simple as that. Let's consider the second one. Okay, so let's test to see whether this exists or not, or whether we'll get an indeterminate form. So let's put 5 straight away and let's see what happens. We have 5 squared, then minus 25 all over. Wherever I see x, you put 5. So I have 5 minus 5. So I have 25 minus 25 over 0. 25 minus 25 is what? 0 over 0. Remember, so this becomes what? This is what? Indeterminate. And for indeterminate, one of the first identity we learned was the difference of what? Of 2 squares. And clearly, this numerator is what? Difference of 2 squares. We know that x squared minus 25 is the same as what? This is the same as x squared minus what? 5 squared, but 5 squared is what? The same as 25. And this is difference of 2 squares, right? What do? You add the terms in one bracket, then in another bracket you subtract them, right? So x minus 5. So therefore, I can say that lim as s approaches 5 of s squared minus 25 all over x minus 5 is the same as the lim as x approaches 5 of the numerator. So the numerator is the same as what? X plus 5, then x minus 5. Then all over the denominator x minus 5. Clearly, this will cancel this, right? So therefore, you know that, so therefore you have lim as x approaches 5 of, you have x plus 5 this way. And this is the same as applying the principles. This is the same as lim as x approaches 5 of x. Then we have 5 here. Then plus lim as x approaches 5 of 5. So I have, whenever you see x, you put 5 there. So lim of x as x approaches 5 is the same as what? 5. Then plus lim of a constant is the same as what? The constant. So 5 plus 5 is what? 10. Let's consider the last question, okay? So for this, remember the identity. A cubed minus b what? Cubed. This is the same as what? A minus b, okay? Then I have a squared. Please, if you are new here, kindly visit my previous lectures where I've dealt or explained the identities, okay? So this is minus, here it becomes what? Plus. Then I have what? The product a times b is what? ab. Then I have plus what? I have plus b squared. So if I have this s cubed minus 1 is the same as what? 1 cubed, which is the same as, I have the x here, then minus what? My b here is what? Is 1. Okay, so this is a and this is b. So I have a squared, which is x what? Squared, then plus 1 times x is what? Is x. Then plus, this is my b. B squared is what? 1 squared, which is 1. As simple as that. So in other words, we can say that therefore, the lim as x approaches 1 of x cubed minus 1 all over x minus 1 is the same as lim as x approaches 1. Then the numerator is the same as this, right? So I have x minus 1, then I have x squared plus x plus 1 all over what? The denominator, what? X minus 1. So this cancels this. So I have lim as x approaches 1 of x squared plus x, then plus 1. And this is the same as lim as x approaches 1 of what? X squared, right? X squared, then plus, you have x here. So you have lim as x approaches 1 of what? X. Then we have what? 1 here, right? So you have lim of 1 as x approaches 1. Right? So let's see what we can do. And this is the same as lim as x approaches 1 times x. X squared means x times x. So times lim of x as x approaches 1, because x squared, right? Then plus I have lim of x as x approaches 1, then plus lim 1 as x approaches 1. So wherever you see x, you put 1 there. So you have 1 times 1, then plus, wherever you see x, you put 1 there. You have 1, then plus lim of a function. That's lim of a constant is always what? A constant, 1. So I have 1 times 1. You have 1, then plus 1 plus 1, 2. So the final answer is equal to 3. Viewers, this is the end of the tutorials. See you next time. Bye.